Okay, so I hope the screen is visible.
Yes.
Yes, sir.
Yes, sir.
Okay, so we were discussing the topic which is mean deviation under the heading of measures of dispersion. So, yeah, so we have discussed that the measure of dispersion can be studied under two categories. One is absolute measures and second is relative measures. So under absolute measures, we have range, quartile deviation, mean deviation, and standard deviation. And under relative measures, we have the coefficient of all the absolute measures of dispersion. So I think we have covered up to mean deviation, if I'm not wrong. Yes, can anyone
Yes, sir. We have done with mean deviation.
okay. Okay. We are done with mean deviation. That means we are left with only the standard deviation, and which is the most popular measure of dispersion, most widely used measure of dispersion. So let us start that. Just- Yeah. Right.
Sir, I think we have like two or three new students here who were first joined today.
Yeah, and I think so. Like Miss Arya Verma, and
Yes, sir.
there's someone with the name Sports Duck. I
Yes,
don't know
sir.
what's the name of the guy. So let it be. The people who have joined for the first time, they can watch the all the recordings of the lectures. They are available on YouTube, and I'll be posting all those. I keep on posting all those on Google Classroom, and you guys might not be available on Google Classroom also. So I'll be posting the code again in the group today, so that the people who have joined late, people who have joined just today, can join the Google Classroom and check the link of the classes available on official channel of UEM Jaipur, right? So all the classes are being recorded and they are there on the channel. So you guys can watch it over there, and still if you find any doubt, you can always discuss them in the class, right? I hope Rishita has seen the earlier classes videos because she has also joined late. Yes, Rishita?
Yes, sir. I have joined 2 weeks late.
Okay, okay. So you gone through the videos available on the YouTube channel?
So not all actually. Like,
Not all, but maybe two, three.
no, sir. I have checked only one. Maybe not full. Also, I need to check. Like,
Okay, okay.
yeah, I'm gonna check all also.
Right, right. No issues. So, all right. So the last topic which we need to discuss under measure of dispersion is standard deviation. See, standard deviation is actually the most widely used and most popular measure of dispersion, and the reason behind that because it actually overcomes all the limitations, all the errors available in other measures of dispersion. And the biggest use, the most widely used area of standard deviation is that whenever we want to calculate the risk associated with some maybe some stocks or some event, we always go for standard deviation. It is widely used over there. Suppose if we talk about the, I mean, if you are given the data of return of a stock, there is some stock, some share is there. So the data of like let's suppose the stock prices data is given to you from last 2 years, from the past 2 years, and you wanted to know that whether what is the level of risk, what is the variation in the return given by this company or the share of this company. So you can calculate the standard deviation, and you can check whether the returns are I mean consistent or they are risky, because the lesser the value of standard deviation, more will be the homogeneity in the data. And if the higher the standard deviation, that means the homogeneity is less, right? So standard deviation, it is represented by the Greek letter sigma, right? And we call it. Let me write it. Sigma. And again, the calculation will study. There is someone who has just joined. So individual data, we have discrete data, and we have continuous data. So in case of individual data, standard deviation is equal to root of summation x minus x bar square upon n. And in case of discrete or continuous, we all know the frequency will be there. So standard deviation or sigma is equal to root of summation f x minus x bar square upon summation f, where what is n over here?
Summation of f.
Number
N
of
is small
Oh,
n,
sorry,
number of
number
observation.
of number of data. Sorry.
Summation of f is also number of observation only, but generally we call small n as number of observation, and like this. So this is the small, I mean very simple kind of a formula which we have, and we need to calculate the standard deviation using this formula. So let us take this question which is available over here, and let us calculate the standard deviation of this data. So we have x and we have f. So x is 2, 4, 6, 8, 10, 12, 14, and 16. And we have frequency 2, 2, 4, 5, 3, 2, 1, 1. So now the formula for this category of question, what kind of a question it is? I mean data is it? It is individual, discrete, or continuous?
discrete.
This is discrete data, right? So in case of discrete data, the formula is sigma is equal to summation f x minus x bar square upon summation f root. Right? Standard deviation is also called as root mean square deviation. So, can anyone tell me what all columns do I need to prepare? Because this is quite similar to mean deviation. This is quite similar to mean deviation. That is why I am skipping some steps, because you can correlate it with mean deviation, because the formula for mean deviation is quite same. Only difference is there is no square. Instead of square, we take the mode, which is like we ignore the negative sign. So first of all, what should I calculate?
So X bar.
X bar set.
X bar. X bar is what? Mean.
Mean.
X bar is mean, right? And the formula for mean is summation fx upon summation f.
F.
So let us quickly find out fx. It is 4, 8, 24, 40, 30, 24, 14, and 16. Am I right?
Yes, sir.
Quickly tell me the summation fx, total of fx. 160?
160.
160. So 160 is summation fx, and what about summation f? 20. Am I?
Yes, sir. 20.
Yeah. So x bar is equal to 160 divided by 20. 8. So 8 is x bar. Now I need x minus x bar first. So find out x minus x bar. X bar is 8. So you have x and you have x bar. So over here we will take negative as negative only. We will not ignore the negative sign. So 2 minus 8 will give me negative 6. 4 minus 8 negative 4. 6 minus 8 negative 2. 8 minus 8 0. 10 minus 8 2. 12 minus 8 4. 14 minus 8 6. And 16 minus 8 8. Am I right?
Yes.
Now I need x minus x bar square. Sorry. So x minus x bar square, x minus x bar are there. It is equal
36.
to 36, 16, 4, 0, 4, 16, 36, 64. Right? So x minus x bar square is done. Now I need to multiply it with f. So I need f x minus x bar square. Now quickly multiply f with x minus x bar square and tell me the total. I am repeating, quickly multiply f with x minus x bar square and give me the total summation. Please cross check.
264.
Total
Yes, sir.
264. So summation f x minus x bar square is 264. So now I need to apply the formula. The formula is this. So standard deviation is equal to root of summation x minus x bar square f into x minus x bar square upon summation f. Summation f x minus x bar square is 264. Summation f is I guess 20. Yeah, it is 20. So I'll apply this. I'll replace the values. So 264 divided by 20. Calculate this. We'll go with the flow, then will be root of 132 upon 10. So root of 13.2. Square root of 13.2.
3.63.
Yes,
3.63.
3.63. This is the value for standard deviation for the given example. Is there any problem with anyone? You can discuss. Yes. Is there any
Sir, बताइए.
problem? No problem.
No.
No, sir.
Okay. Then let me find out one question for you.
Sir, have you just multiplied x minus x bar whole square with the frequency for the summation part? Okay.
No, we
Can
have,
you go to the
see, there is one.
slides?
I got your question. I think you are
Yes.
saying that, sir, can we
Yes, you
take.
multiplied there, right, sir?
Yeah, I have multiplied the individual frequency with the individual value. What
Yes, sir.
happens in during the examination, student what used to do? They multiply it like this. Never do it. Like they take the summation f, they take the summation of x minus x by square, and then they multiply it. This is wrong. You have to take
Yes.
the individual values and multiply it with individual value of this, and then get this.
Then we need to do the summation of that,
Yes,
right,
you
sir?
need to take the total, which is 264.
Okay, sir.
So the question is in front of you. Calculate the value of standard deviation and post your answers into the. Okay, don't post them in the chat box. I'll ask one by one individually. You just complete it and just post in the chat box that you are done.
Sir,
Yes.
done.
Okay. Okay. Let's wait for others to respond. Divya is also done. Divya and Abhijit have done it. What about others? There are around eight, 7, 8 people in the class, so only two have responded till now.
Yes, sir. Just a second.
Yep. If anyone is having any problem in solving it, then also please ask. If even a single percent doubt is there in formula, in calculation, then also please ask. Don't take it like that sir has given the question, so you will have to solve it. You have to solve it, but first you should be clear with the concept.
Yes, sir. Done.
Okay, so three people have done it.
Yes, sir. Done.
Four. So 50% of the class have done it. So Rishita,
Okay.
okay. Rishita, what is the answer?
So 1.149 approx.
1.149 approx. Okay. Okay, so all five of you, please post your answer into the chat box quickly. 1.149 is Rishita. Rhythm is 1.055. Abhijit is 1.15. Okay. Divya is 1.149. Prashant is also 1.149. So there is a slight variation in the answer given by Rhythm Abhijit, and Divya and Prashant are getting the same answer, and I think
So this is the approx one because there are so many decimal places actually.
But the first two decimal places would be same.
So I got the same answer of 1.149 and I just rounded up 1.5,
Okay, yeah,
1.15.
yeah, yeah. Abhijit is also getting 1.15. So, Rhythm, you are getting 1.05.
Oh, so I didn't mean a mistake. Yeah. Sorry, sorry.
Have you found the mistake?
Yes, I guess it's in the calculation for f in that thing. X minus x bar square.
Okay, no issues, no issues. So, all the people are on the same answer, same track. So, standard deviation for the given question is 1.14, which is approximately can be said as 1.15 also. Both are acceptable. So, this is all. Now we can take one more question. Just a second. Hmm. Okay, so quickly let us have one last question for the topic and then we can start fresh from Monday. So the question is not class, it is marks and number of students. So marks start from 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, and 60 to 70. Number of friends are 5, 12, 30, 45, 50. This is 50, 37, 21. So this is the question. We need to find out the standard deviation. Start doing it and try to finish it within the class duration only. Because we have more than 10 minutes right now and it should not take more than 10 minutes to solve this. So start working on this.
So in marks, that would be the x, right?
Sorry?
So the marks would be the x, right?
Yeah, groups, classes.
So what should I take from that 0 to 10 mean?
See, you need to, in order to calculate standard deviation, you need to find out the mean. Now, how to calculate mean for the continuous data? Can anyone from the class, apart from Rishita, because she was not there in the class when we have discussed it,
Sir, I
Abhijit,
know how to find the mean. Right?
okay,
Can I just say this?
yeah.
Let's
So
see if it works on like
what were
upper
you
limit
asking?
plus yes sir.
Hmm. Yeah, yeah, please,
Upper
please.
limit plus
Hmm.
lower limit divided by two.
Yeah, mean marks. Yeah,
Yes, then the marks would be like for the first that would be five, right? X.
yeah. First
Okay,
X
sir.
will be 5, then 15, and then gradually increasing by 10.
Okay, sir. Okay.
So,
Sir, done.
Okay, good. What is the answer?
Sir, 14.839
Yeah,
approx.
right. Good, very good.
Thank you.
Okay, what about others? And the attendance is quite low today. I mean, we always have more than 10 students in the class. But today, as I can see, there is only six students, six, seven students. So, why so? Any idea? Okay, no issues. Divya, Abhijit, Rhythm, what about the question?
Yes, sir. Done. 14.839.
14 points. Right. Okay. Right answer. Good. Who else is left? So out of six, two people have answered. So that's very good. Uh,
So,
yes, yes.
when we calculated x bar, the answer that came is 40.9. So I rounded that off to 41. So in that case, like that won't be a problem in the main answer.
See, if we take 40.9 as 41,
Hmm.
there is hardly any problem because approximation is always there. But in case if we are dealing with a very small kind of a data and we are having calculator along with us, so instead of rounding it off, let us take it like this only. Right? You can
Okay.
round off. I mean, 40.9 can be taken as 41. So no issues in that. No problem at all. No, because it will
Okay.
hardly makes any difference. If it is the 40.2 and we are taking it 41, then there will be a kind of an error. But 40.9 can be approximated up to 41, so no issues in that.
Okay.
Acceptable. It is acceptable. Yeah, so that's all for today, and we'll be starting the new topic from the syllabus from coming Monday. So take care, bye, and test is scheduled. So please do mark your attendance via test because that is something which is required in order to mark you present in the class. So please do that. It is active up to 4 p.m. only. So just after this class, please respond to that, right? Okay, so I'll see you on Monday. Thank you. Thank you.
Thank you,
Thank
sir.
you, sir.